the power, the coefficient is 1, and then we have the variable as x. Then we're going to have n multiplied by the coefficient of x, which is of course 1, and the coefficient of x, and then we're going to have 6. Then we have x, we subtract 1 from the power. Onto the second example. How do we do? Welcome to this video, and in this series we are going to begin a new chapter known as differentiation. A majority of you have been requesting for this topic, calculus, and we're going to begin with calculus 1, then calculus 2, and then we're going to also talk about advanced calculus. So we're going to begin with calculus 1, and in calculus 1 we're going to categorize it into differentiation. Then calculus 2 we are going to talk about integration, and then in advanced calculus we are going to talk about derivatives and maybe partial derivatives and so on. So let us start off. What we mean by differentiation, how to differentiate. So that is the first thing we're going to talk about. How do we differentiate? Now, if a function of y with respect to x is given as, so we are having a function with respect to x. Sometimes we say a function of y with the variable being x. So if this is a function of y with respect to x with a given power n, then if you want to do the derivative, or what we call the first derivative of this function, sometimes written as dy over dx, or sometimes you can have it as y prime, can be given as, now we take the power, we multiply the power by the coefficient of x, and then we subtract 1 from the power. So what do I mean? So if we have n as the power, the coefficient is 1, and then we have the variable as x, then we're going to have n multiplied by the coefficient of x, which is of course 1, and therefore it's going to be n, and then in the power we subtract 1. So that is going to be n minus 1, and this becomes the way to find the first derivative, or how to differentiate a function of y with respect to x. You can have so many functions. For example, you can have in kinematics, sometimes we use a function of s with respect to t. That is a displacement with respect to time. You can also have a function of displacement, or that is you can also have the function of velocity with respect to time, and so on. And all those, we apply this law of differentiation to work out. We are also going to derive the first law of differentiation in our preceding videos, but for now, this one, we call it the first derivative of a function y with respect to x. So the moment you find the first derivative denoted by y prime, then that becomes the first derivative of that function. Now, what about the derivative of a constant? What if we have a constant? For instance, we are having a constant in our examples here. So how do we treat constants? Because you notice that in a constant we don't have coefficients, or we don't have variables. How do we treat that? Now, we can try to have a constant like 3. So if we want to differentiate this one, we're going to assume that it has a variable x to power 0. And remember, any number to power 0 is 1. And therefore, if we multiply 0, and the first derivative of this is going to be equal to, we multiply 0 by 3 is going to be 0. And 0 multiplied by x, of course, it remains to be 0. And therefore, we conclude that the derivative of a constant is always a 0. Now, for us to understand better, let us now look at the following 2 examples. And of course, in our preceding videos, we are going to do so many examples of this, and therefore follow our videos for more. Now, in the first example, we are having a function of y is equals to 3x squared plus 3. That is a function of y with respect to x. And now we are supposed to differentiate this function. So how do we go about it? Well, So we can write this as dy dx or y prime. Now we are going to take the power multiplied by the coefficient of x, and then we're going to have 6. Then we have x, we subtract 1 from the power, we have, so let me do it better. You're going to have 2 multiplied by 3, 2 multiplied by 3, then x raised to 2 minus 1. So this becomes the first hand. We have taken 2 multiplied by the coefficients, and then we have x power. In the power, we subtract 1. And then we have plus. Now here, we're going to have 3. We're going to have here, we're going to have, this means this is x, 3x power 0. This means it is 3x power 0. And if we multiply 0 multiplied by 3 is 0. And therefore, this ends up to be a 0. Well, so that means dy dx, or the first derivative, or sometimes written as y prime, is going to be equal to 2 times 3 is 6 x power 1. Of course, we don't write power 1 because it is automatic. It is raised by 1. On to the first. On to the second example. How do we do this? So this one, y prime, or the first derivative, is going to be 3 multiplied by 3, x power 3 minus 1. That is the first derivative. 3 multiplied by 3, x into raised to 3 minus 1, plus 2 multiplied by 2, x raised to 2 minus 1 again, plus, now this is to power 1, x power 1, 3 multiplied by 1, multiplied by x, 1 minus 1, and minus, because this is going to be 0, because we have said here that the derivative of a constant is always 0. And therefore, the solution for this, y prime is equals to, is going to be 9x squared plus 4x plus x raised to 1 minus 1. 1 minus 1 is 0. Any number raised to 0 is 1. Therefore, we have 3. And that becomes the derivative of those two functions. So that's how it's done.